Here is a single byte of memory. 10010110. Is it the number 150? Or is it a command telling the processor to add two values together? Staring at the bits alone, you genuinely cannot tell. The answer is the secret at the heart of every computer. The processor itself decides, by the role each pattern plays as it flows through a small set of working parts. Today we open the machine and watch those parts come alive. Early machines had no flexibility. To change the task, you physically rewired them, by hand, for hours. Von Neumann's breakthrough was simple but radical. Keep the instructions in ordinary memory, sitting right alongside the data they work on. Now the same wall of bits can be read two ways. As data, it is a value to crunch. As an instruction, it is an order to obey. Nothing in the pattern marks which is which, only the moment the processor reaches for it. Step inside the processor and you find registers, a handful of tiny, blazing fast stars, each with one fixed job. The program counter holds the address of the next instruction. The accumulator holds the running result of calculations. Two more handle memory traffic. The memory address register names the location we want. The memory data register carries the bits traveling to or from it. And the current instruction register grips the instruction being decoded right now. At the center sits the arithmetic logic unit, the part that actually computes. It pulls values from the registers, adds, compares, or applies logic, then drops the answer back into the accumulator. The control unit, meanwhile, conducts the whole performance. The processor talks to memory along three bundles of wires, together called the system bus. The address bus carries one thing only, which location. It runs one way from processor to memory, like calling out a house number. The data bus carries the actual bits, and crucially it runs both ways. Values flow out to be stored and back in to be processed. The control bus is the timekeeper, firing read and write signals so every pot acts at the exact right tick. Now watch it all turn. The processor runs one endless loop. First, fetch. The program counter hands its address to the memory address register, and the instruction at that location is copied back over the data bus into the memory data register. Second, decode. The instruction moves into the current instruction register, and the control unit reads it apart, deciding which circuits to switch on. Third, execute. The action happens. The arithmetic logic unit crunches numbers, or data is written back to memory. Then the program counter ticks up by one, and the loop restarts, billions of times each second. That relentless fetch, decode, execute rhythm, and nothing more exotic, is what turns a box of switches into a computer running your every program. The deepest idea is the stored program. Instructions and data live together in one memory, made of identical bits, and only the processor's use of a pattern decides whether it is a number to crunch or a command to obey. Inside the processor, dedicated registers each hold one thing, the arithmetic logic unit does the computing, and the control unit conducts. Three buses link it all to memory. Address one way, data both ways, control keeping time, and it all runs on one loop. Fetch the next instruction, decode what it means, execute the action, then step the program counter on. Repeated billions of times a second, that simple heartbeat is the whole of a working computer. How those instructions are actually written comes later.